welcome back. Today we are looking at question 8b. Last time we looked at question 8a, which was involving angle of depression. And today let's look at the b quickly, so that maybe we can add the question 9 to it. Now, if you look at the question 8b, it's a question on rhombus. They say one of the diagonals and perimeter of a rhombus are 32 centimeters and 80 centimeters respectively. Respectively simply means that the first one goes for the first and the second goes for the second. So the diagonal is for the 32 centimeters and the perimeter is for 80 centimeters. So the perimeter of a rhombus is what? 80 centimeters. Find the area of the rhombus. Okay. Now rhombus and square most of the times looks alike, but they are not the same. Okay. They look alike, but they are not the same. If you look at rhombus, the only difference between rhombus and a square is that if you take of them, square has all the sizes equal. Rhombus also has all the sizes equal. It's a square. Rhombus has all the sizes equal as well, just like the square. So the only difference is that the square has the edges meeting at 90 degrees. The square has the edges meeting at 90 degrees. But for rhombus, their edges don't meet at 90 degrees. So that's the major difference between a rhombus and a square. So you can have a sketch of the rhombus. Let's have a sketch. We can draw a nice rhombus here with all the sizes equal. Okay. So this is a typical example for rhombus with all the sizes equal. Okay. But the angles over here do not meet at 90 degrees. That's what we mean by the edges. So the angles over here are not 90 degrees like the square. The square has the angles to be 90 degrees across, but rhombus, the angles are not 90 degrees. So they said this rhombus over here has the perimeter, the distance around it is 80 centimeters. If the distance around it is 80 centimeters, and we know that the sizes are all the same, then it means that this side plus this side plus this side plus this side give us 80 degrees, and therefore each side will be 20 centimeters, right? Okay, so you can see the length, which is L, 4L. Okay, 4L. 4L equals 80 centimeters, right? Good, 80 centimeters. So if we are looking for one length, then we can say L equals 80 out of 4, and this one should give us 20 centimeters. Okay, so a side of this rhombus that they are talking about is 20 centimeters. Okay, now one thing about rhombus is that their diagonals bisect each other. Okay, their diagonal bisect each other. So you have this diagonal going this way and this one coming this way. They bisect each other at angle 90 degrees. So rhombus, the diagonals of rhombus bisect each other at 90 degrees. Okay, so we have here to be 90. So here is 20 centimeters. Okay, and they are saying that the diagonal of a rhombus is 32 centimeters. So one diagonal has been given, which is 32 centimeters. So if their diagonal bisect each other and one diagonal is 32 centimeters, then you could see that one side of the diagonal could be, let's say, 32 divided by 2. Okay, so making 60 degrees, 16 centimeters rather. Okay, so if the entire length of the diagonal is 32 centimeters, then the half of it will be 16 centimeters. Okay, so in that case, you could see that we have a certain angle, a certain shape here. Here is right angle, then here can be our hypotenuse, and you can see we have a right angle triangle over here. Therefore, we can find this length over here, because for we to be able to find the area of the rhombus, you know, area of a rhombus has about 3 formulas. Okay, we have about 3 formulas. We have the first formula to be half multiplying the product of what? The diagonals. The first formula. You could use half multiplying the product of the diagonals, which I think would be appropriate for this particular question. Okay, the first formula, which is the product of the diagonal multiplying half. Okay, that's one way of finding the area of a rhombus. Then the second formula is the altitudinal height. When you take the altitudinal height, okay, the altitudinal height times the base. Okay, the altitudinal height times the base. Then we have the last formula, which is the trig ratio using the sign. Okay, good. So here, if you look at it, I think the first formula is the one which will be appropriate over here. Okay, because we know of one of the diagonal, we are only left with the other diagonal. Okay, so if we get the other diagonal, then we can peacefully find the area of the rhombus. Okay, good. So in this case, now that we know that this side is 16 centimeters, the hypotenuse is 20 centimeters, then I think we can find this section. Okay, this is the other section. So by using Pythagorean, you can see that we have 20 square, okay, equals 16 square, plus this section which we don't know. So let's label it with a letter. Let's say x. Okay, so plus x square. Okay, so the hypotenuse square equals the sum of the squares of what? The other two sides. Good. So this one will give us, we have this one to be 400. Okay, equals here will give us 256, right? Then we have plus x square. So we send this one to the other side. Then we have 400 minus 256 equals x square. Then we have 144 equals x square. Then we take square root of both sides. Okay, so this will cancel this one off. Then our x will be equals to is a 12. Okay, 12 centimeters. 12 centimeters over here. So it means this section from the top to the center over here is 12. So what will be the entire length? So 12 plus 12, making 24. Okay, making 24. So in that case, we can say that can bring our section here. We have area of a rhombus. Area equals diagonal 1, okay, times diagonal 2 out of 2. Okay, half multiplying the other two diagonals. Okay, half multiplying the two diagonals. So we have area will be equals to, now we know that the first diagonal was 32, so 32 times, now we know the second one to be 24. Okay, is it divided by 2, right? Divided by 2. So here we have the area to be equal to we have 32 times 24, which will give us 768 out of 2. Okay, out of 2. Then what do we have? Is it 384? So area equals 384 centimeters, right? Yeah, centimeters. So centimeters square. Okay, so this is the question 8B. Last time the video was very long, that's why I didn't include it, but this the B part. So anytime you get a question on the rhombus, this is the procedure. It's either you use the area. You have 3 ways. You can use the product of the diagonal divided by 2, or you can also choose to use the the altitudinal height times the base. You can also use that one. Then the trig ratio. Okay, so this is the procedure and the solution to question 8b. Thank you. Bye bye.